All right, so the terminal sides of alpha and beta are not in quadrant 3. In which quadrant is the terminal side of alpha plus beta? Okay. So first of all, what was anybody able to find out what quadrant alpha is in, or the terminal side? 2. Why? Because it's negative, so that means either 2 or 3, but it says it's not in 3. So alpha is in quadrant 2. So here's alpha, and so our reference angles, we'll call it alpha prime. If the hypotenuse is 1 here for this right triangle, it says the cosine of alpha is negative 3/5, so negative 3/5 would end up here. Okay, and so we just need to know what the sine is, which is our y value. If you use Pythagorean theorem, what do we end up with? 4/5. So if we take the square root, we get y is plus or minus 4/5. But because we're in quadrant 2, we're going to go with the positive. So 4/5 is going to be the sine of alpha. Okay. And then we got to work with beta. We know the sine of beta is negative, so that means it could be either in quadrant 3 or 4, but it tells us beta is not in quadrant 3, so we know that beta is in quadrant 4. So here's beta. So beta prime is going to be our reference angle. Hypotenuse is 1. Sine is negative 8/17. That's your y value. What are you guys getting for x? (15/17). Okay. So x squared plus negative 8/17 squared is 1 squared. 17 squared is 289. Equals 289/289. Subtract 64 from 289. Get 225. You take the square root, you get positive and negative 15/17. And because we're in quadrant 1, our x value is going to be positive 15/17. Okay, so that's our setup. Now to come up with an explanation for alpha plus beta, or to find out where alpha plus beta is, we're going to find the sine of alpha plus beta and find the cosine of alpha plus beta. And based on what we end up with, we'll find out what quadrant we're in. So the sine of alpha plus beta, did you find that yet? So go ahead and solve for that if you haven't yet. What are you guys getting? 84/85? Okay. So that's the sine. We're going to run out of time here. The next thing we're going to do is find the cosine of alpha plus beta. right? And then based on what we get there, we'll determine what quadrant we're in. We'll finish this one tomorrow. So just to recap where we were, um, we're given some information about alpha and beta, two angles. From that information, we find out what quadrant they're in. We can build triangles, and we use Pythagorean theorem to do that. And then we're asked to find out, like in this example, we're asked to find out where is beta minus alpha. So I don't even know what those two angles are, but if I subtract those two angles, what quadrant will I be in? And our method for figuring that out was to find out what's the sine of beta minus alpha and what's the cosine of beta minus alpha. And because both the sine and the cosine are negative, and sine kind of acts like your y value, x acts like your cosine acts like your x value, well, they're both negatives, so that would put us in the third quadrant. And then lastly, you got to finish off with a good explanation, and that work, with that supporting work, an explanation like this, beta minus alpha is in the third quadrant because sine is negative and so is cosine. It would be a good, sufficient answer. And then we were almost finished number two. Number two, we were told that alpha and beta are not in quadrant 3. We're also told that the cosine of alpha is negative, so that puts alpha in quadrant 2, the terminal side. And we're told that sine of beta is negative, so that put us in quadrant 4, because neither can be in quadrant 3. And then after using Pythagorean theorem, we find the 3 side lengths of our triangles, and we found the sine of alpha plus beta was positive 84 over 85, and we were just getting started with finding the cosine of alpha minus beta, or at least I was. Maybe you worked ahead of me. So this is where we stopped, and cosine of alpha plus beta. You can use your cheat sheet, but we've been doing this over and over. Some of you are maybe starting to memorize these formulas. We have cosine alpha, cosine beta. At least I'm memorizing them. Minus sine alpha, sine beta, right? And from our pictures, the cosine of alpha is negative 3/5. The cosine of beta is 5 over 17. Minus the sine of alpha, which is 4 over 5. And the sine of beta, which is negative 8 over 17. And continuing to work through this, negative 3 times 5 is negative 15. 5 times 17 is our 85. Minus 4 times negative 8 is negative 32 over 85 again. And you have a double negative, so that's going to be a plus. So what is negative 15 plus 32? 17. So we get 17 over 85. And what's important here is it's positive. Question? Maybe. Oh, it should be 15 over 17, not 5 over 17. I copied that down wrong. Thank you. So that's going to change it a little bit. Let me backtrack. So it's going to be a 45. So negative 45 plus 32, that's going to change the sign. It's going to matter here. And we end up with a negative what? Negative 13. Okay. So our cosine's negative and our sine is positive. And so there's only one quadrant where sine is positive and cosine is negative. What quadrant would that be? 2. And so we need to give a good explanation. You could say that alpha plus beta is in quadrant 2. because the sine of alpha plus beta is positive, and the cosine is negative. And there we have it. All right, so let's take a look at the homework, and I'll work through one of the problems with you. It doesn't matter which one. We'll pick one. But let's take a look at the homework. So number one asks you to find the sine of alpha plus beta, and then in part B, that's the part A. Part B says what quadrant is alpha plus beta in, and so what else would we have to calculate? You could, yeah, so you find the cosine. So if you have the sine and cosine, then you can finish that off, and you justify your answer like we did. Number two is like that as well. Number three, you have part A, but they don't give you part B, and that will be fine. I was thinking of making you do part B. So on 3, you don't have to write a justification. You just find cosine of alpha minus beta. So we'll just have that practice. Okay. 4, you're given tangent. You're finding tangent, and if you find tangent of alpha minus beta, well, you don't have to do B. But if I asked you about alpha minus beta and you found tangent, would you have to find sine and cosine as well? Is it enough to know tangent and sine, or tangent and cosine? Like if I told you the tangent was positive and the cosine was negative, would you know what quadrant you're in? Yeah, so you don't have to have sine and cosine. You can have tangent and one other as well. So that's all I'm saying. And that, so 5 is very similar. You got to have your explanation, same as 6, and same as 7. So I will do one of these with you. Doesn't matter. Any requests? Number 3. Okay. So 3, there's no part B to. Is that fine? So 3 is only like half a question. 4 is only half a question. All right. I heard 2, so I'm going to go 2. Okay, so we're going to do 2. So cosine alpha plus beta. We're given the sine, and we're given the sine of alpha and the sine of beta, and we're told that alpha and beta are in quadrant 2. And so I'm going to start by drawing a picture for alpha. So alpha's in quadrant 2. Draw a right triangle in quadrant 2. And remember that if your hypotenuse is 1, then the side opposite your reference angle is the sine. So our sine of alpha, we'll put alpha prime in here, is 12 over 13. And then if we know 2 sides of a right triangle, we can find the third side using Pythagorean theorem. And so I'll call that third side x, and solve for x. So x squared plus 12 over 13 squared is 1 squared. And I'm going to get a common denominator. And we end up with x is positive or negative. We got to decide which one. 5 over 13. So should x be positive or negative? Negative, because we're in quadrant 2. So we're going to make that negative 5 over 13. And so now when we're asked questions about the sine or cosine of alpha, we can answer that. The sine of alpha is 12 over 13. The cosine of alpha is negative 5 over 13. Now we got to do something similar with beta. It tells us that beta is also the terminal sides in quadrant 2. Hypotenuse is 1. And the sine of beta is 4/5. And we can solve again for our x value, which is our cosine, using Pythagorean theorem. We get x squared is plus 16 over 25 is 25 over 25. So x squared is 9 over 25. And so x is going to be positive or negative. We got to decide 3 over 5. And because we're in quadrant 2 again, we're going to say negative 3 over 5. This is for beta. So from this piece, we can conclude, okay, the sine of alpha is, well, given to us. Sine of beta is given to us. I'm not going to write this. But the cosine of alpha, we found, is negative 5 over 13. And the cosine of beta is negative 3 over 5. So now we can use our formula to find cosine of alpha plus beta. And your formula says that that's equal to cosine of alpha cosine of beta minus the sine of alpha, the sine of beta. And plug in our values now. Cosine of alpha is negative 5 over 13. Cosine beta is negative 3/5. Sine is 12 over 13. And 4/5. When we multiply our fractions, we get positive 15 over 65 minus 48 over 65. And 15 minus 48, negative 33 over 65. Can we reduce that at all? I don't think so. So we found our cosine. So that was part A. So then part B is saying, well, then what quadrant is alpha plus beta in? So we need one more piece of information. We can find the tangent or we can find the sine. Either one would work. It's easier to find the sine. So we'll find the sine of alpha plus beta. We've done all the work already to find the cosine of alpha and beta, so we don't have to do that again. So we're going to find the sine of alpha plus beta. And using our formula sheet again, we find that that's the sine of alpha cosine beta plus sine beta cosine alpha. And then plug in, substitute in those values. So sine is 12 over 13. Cosine of beta is negative 3/5. Sine of beta is 4/5. And cosine of alpha, negative 5 over 13. So negative 36 over 65 minus 20 over 65. And that's negative 56 over 65. So I want you to get the correct answers for the sine and cosine. But for our explanation, we don't really care about the value. We just care if it's positive or negative. And we find that they're both negative, which leads us to what quadrant? The third quadrant. So our justification says justify your answer to part B. Our justification is going to be alpha plus beta is in quadrant 3. Because sine of alpha plus beta and the cosine of alpha plus beta are both negative. And we can see that in the work. So there's our explanation, and we have supporting work to go with it. And so that is pretty much what you're doing for each of these problems. Okay. Being careful as you're working through, there's lots of little steps. Be careful not to make a little mistake. And as you're working on it in class, you can check with people around you, see if you're getting the same answer. Okay. So I'm going to stop there.